Okay, this is a follow-on from the last lesson. You might notice that the notes that you might need to get are not that different. That's why we're doing these two lessons together, okay? Sometimes you're going to have equations that have multiple or repeated unknowns, x in multiple different places. How you deal with that, that's what this lesson is about. So can we remember, terms are anything separated by a plus or a minus sign. Terms are alike if they have the same variable to the same power. How do I solve equations with repeated unknowns? Step 1, expand any brackets in the equation. Step 2, collect like terms. Step 3, make sure there's only unknowns on one side of the equation. LHS, so someone asked me what LHS stands for, left-hand side. Most of you guys would prefer having your x on the left-hand side, x equals something. But does it matter? If I wrote 5 is equal to x, is that the same as x is equal to 5? So it shouldn't matter, but you've been built up to want your variable on the left-hand side. If you're looking to do advanced maths, it shouldn't matter. Equal signs go both ways. So step 3 was make sure there's only unknowns on one side of the equation. Left-hand side is usually the best. And then once again, this was step 2 from last lesson, you use inverse operations on both sides to isolate the unknown. So writing time, just to get those steps there, and I'll demonstrate. So this is a shorter lesson because I'm not going to go on a massive tangent to teach you stuff that I would have personally taught you if I had you previously. Expand the brackets, collect like terms. Make sure unknowns are on one side. And the inverse operations again. If anyone's watching that OG lesson YouTube video, I'm literally going to take it down now because there's no sound on there. Delete forever. I'll record that sometime today. Step 1, are there any brackets in example 1? Yes or no? Yes? Can someone tell me? You should have done this in year 9, but I don't like to assume anything. How do I expand those brackets? What do I do with that 5 on the outside? Yes?
You times it.
Times it. You times it by each term within. Oh, it's not. 5 times by x is 5x. 5 times by 1 is going to be 5. So your first line of working is to expand. It's going to be 5x plus 5. Did I do anything with a negative 2x? No. Equals negative 7. Are there like terms here?
Yes.
Is there same variable, same power? 5x, negative 2x. If I have 5 x's and then I subtract 2 x's from that, how many x's will I have? 3. So 3 x's. Did I do anything with that plus 5? No, that remains. See how suddenly this is what you were doing in lesson 1. What was the only difference? You had multiple x terms. How do I get rid of that adding 5? Minus 5, 3x plus 5. Take 5 in a box. Take 7, take 5 in a box. Plus 5, take 5, you're going to have 3x by itself. Negative 7, take 5. Where are we going to be at on the number line? Negative 7, and then I step to the left even further, 5. Negative 12. What is the 3 doing to x? It's not dividing. That's what you're going to do to get rid of it. You're multiplying. Divide by 3 to get rid of it. 3 over 3 is 1, so therefore x is equal to negative 12 divided by 3 is negative 4. Stamp. Get the example as needed. Just that first example for people. Some people have done that. You can get the second one. You can see it's a little more challenging there. That's the point. Just a reminder, I haven't put a notice about it yet. Lunchtime, D17, the middle room in the maths block at the top. I do lunchtime tutorials there. If you need extra time or face-to-face, that's every day. Usually it's other classes students that come up, but if you need the help because it's a bit intense for you, you're struggling to get back into learning mode, use it. Example 2. How many sets of brackets are there in example 2? 2. We need to expand them all as part of step 1. What's the first set of brackets expanded going to look like? 6 times by 2? 12. 6 times by negative x? Minus 6x. Plus 5x, I didn't do anything with that, equals 3. Here, you need to be careful. Because the problem is through primary school and earlier level maths, the way that you're taught it is 3, take 7, etc. It's actually better to look at everything as like blocks. This is a term. This is a term. This is also a term. Because if you say it's take 7, you might multiply the x and the 3 by positive 7. But it's not. What kind of a 7 is in front of the second set of brackets? Negative. So when you expand that, what's negative 7 times by x is going to be negative 7x. What's negative 7 times by 3? Negative 21. Do I have a bunch of like terms right now? Are they on either side of the equation? So now you're doing what lesson 2 is about, which is bringing them all together. I've got 12. If I've got negative 6x, and I add 5x to it on the left-hand side, how many x's will I have? Yeah, you don't need to whisper, right? No one can tell it's you on the video. Say it with your chest. Negative 1x equals, see how I combined everything on the left-hand side? Are there like terms on the right-hand side? Yes, which ones?
3 and negative 21.
Well done. Like terms also include just numbers. What's 3 take 21?
18. Oh,
Negative 18. So you've got negative 18 take 7x. Now you've got this situation. That's what step 3 is for. Make sure there are unknowns on only one side of the equation. Do we have unknowns on multiple sides right now? I can't isolate x. X is not isolated. I think the video's recording, so just... X is not, I can't get x by itself if it's on both sides. So what I initially told you was, do you guys prefer the x on the left-hand side? Let's do it your way and then we do it my way after. So let's get everything onto the left-hand side. I want my x's on the left-hand side, so I want to get rid of this. What's the opposite of taking 7x? If I add 7x to both sides, I'm going to have 12. I'm going to have 12. What's negative 1x add 7x? Good. 6x equals negative 18. Now we're back to what you were doing in lesson 1. What's the opposite of positive 12? Say louder. Negative 12. If I take 12 from both sides, it's going to be negative 30. Well done. What's the opposite of timesing something by 6? So x is going to be negative 5 in this scenario. That's your way. That's going left-hand side. Why I like maths, there's nothing subjective about it. It is objective. If you do correct maths, you can do it whatever way you want. I'm not going to take marks off because you didn't do it my way. I'm going to take marks off because you did maths wrong. So let's do it the other way. Let's put everything on the right-hand side. So here, what would the opposite of taking 1x be? Plus 1x. So we're going to have 12 equals negative 18. What's negative 7x plus 1x? No, you're adding 1x to negative 7x.
6x.
Negative 6x. Because you're adding to it, you go further to the right. Negative 6x. What is, I want to get rid of this. What's the opposite of taking 18?
Adding 18.
If I added 18 to both sides, do I get 30 equals negative 6x? What's negative 6 doing to x? What's the opposite of multiplying by negative 6? Is the answer the same? Is dabbing still a thing? No? Okay. Let the record show, on the recording, Mr. T, may or may not be dabbing right now. Can you see it doesn't matter which side? I prefer left because I grew up on it, but an equal sign goes either way. Okay? There are no more examples.